Okay, so let's look at mixtures and matter. So remember that matter is anything that has mass and takes up space. So when we start looking at a mixture, this is the combination of two or more pure substances. Remember, pure substances can be elements, they can be compounds, but when we mix them together, they still retain their individual properties. And so let's look at the two different types of mixtures that we have. One is a heterogeneous mixture and one is a homogeneous mixture. Remember, a heterogeneous mixture has individual components, such as hetero means different, homo means the same. So an example would be like trail mix. We can still pick out the peanuts and the raisins and all that. And then a homogeneous mixture is where you have a consistent composition throughout. An example of this would be a solution. Solutions are really important for chemistry because we mix different solutions as reactants together to form new products, such as most of our ionic compounds aren't reactive when they're solids, but they're very reactive when they're in liquid form or solutions. And so an example would be like lemonade, children's Tylenol. These are really great solutions. We also have solid solutions. This would be things like steel. When we take 2 or 3 or 4 metals together, we melt them. What happens is, as they're melted together, they actually will harden to form a solid new metal called an alloy. These alloys are typically stronger than the individual metals that are in them, such as iron is part of steel, but steel is much stronger than iron and it doesn't oxidize as quickly. So let's look at these a little closer. So again, pure substances, elements and compounds, mixtures, homogeneous or heterogeneous. Let's identify a few of these types of matter. So the first one up here in the corner, can you guess what it is? That's right. It's a heterogeneous mixture. This is just a normal tossed salad. It has lettuce and cheese and carrots and tomatoes and croutons, and we can pick out each of the individuals. That's a great example of a heterogeneous mixture. What about this tall drink of water? Yes, it is a compound because water is composed of 2 hydrogen bound to 1 oxygen. It is a compound and therefore it is a pure substance. The next, down on the bottom left, you bet, that is steel. So that is a homogeneous mixture. And this, a little trickier, it's muddy water. Muddy water is a heterogeneous mixture. It is known as a suspension. This suspension has big particles, and if you would let this settle out, you would have mud at the bottom or dirt and water at the top. Here we go. A gold bar. Yes, gold is an element found on the periodic table, so it is a pure substance. And what about this one? This is oil. Specifically, I believe it's vegetable oil. Yeah, that is a homogeneous mixture. It's evenly distributed throughout, but each of the individuals are still there. So when we start talking about these mixtures, we can separate them. So we do have some physical separations, but some easy ones are filtration, where we can actually use filter paper, which makes a barrier that we can separate a solid from a liquid. Distillation. Distillation is the separation using boiling of different substances. Crystallization, which we will sometimes call evaporation. This is where you will separate a solid from a liquid, such as you can separate salts this way. And then chromatography. This is where you can use paper, which is a very porous paper, and you can separate different types of materials across it. So let's look at each one of these. So the first one is filtration. If you can see here, we have a mixture of sand and water, and then we put a filter paper in, and then we have our sand and our water. They're separated completely. So this would be filtration. The next is distillation. So in this one, we are simply condensing a salt solution, and we're separating this very easily out through a condensation tube, and we can separate that out. Now, this is also a form of crystallization because you'll have these salt crystals at the bottom. Fractionated distillation is a little bit different. It's still distillation, but in this case, we're separating two separate liquids. So we have ethanol solution down here, and ethanol has a much lower boiling point than water, so that we can boil the ethanol, but it doesn't start a boiling point for the water. And so you can have the water and ethanol separated out. We can also use a physical separation means, like based on its intrinsic properties. By the way, all these separation techniques are based on the intrinsic properties of the substances that we're separating. And so we can use a magnet. So if we have sand and iron mixed together, you can have our magnet over top and it will pick up all the magnets. We can use evaporation to form crystallization. It's also so we can have our solid salt water, evaporate all of that out. The water just evaporates into the atmosphere and you're left with a solid salt. This is also known as crystallization. And last but not least, chromatography. And so right here we have an ink spot and we have paper strips. We put it into water and then we have the chromatography or the ink going up and it separates out. And that is how we separate